Welcome back to my channel. I am S.N. Kubendra from Sri Venkateswara College of Engineering. So today's subject is going to be about mathematics, and today's topic is going to be about analysis of variance in mathematics. So let's see what are the contents in this presentation. So first, introduction of ANOVA, one-way ANOVA, two-way ANOVA, problem application of ANOVA, and conclusion. So let's start the presentation. So what is ANOVA? Introduction to ANOVA. ANOVA is a statistical method used to analyze the difference among group means in a sample. ANOVA helps determine whether there are statistically significant differences between the means of three or more independent groups. Key concept to remember while solving ANOVA problems. Variance. Measure of how much the data values differ. Mean squares. Variance estimate computed for the between group and within group variations. F-test. Statistical test used to compare the variability between groups to the variability within groups. One-way ANOVA. Explanation of one-way ANOVA. One-way ANOVA is used when there is one independent variable with three or more levels. Example. Comparing the effectiveness of three different fertilizers on crop field. Formulation of hypothesis. Null hypothesis. There is no significant difference between the means of the groups. Alternative hypothesis. At least one group mean is significantly different from the others. Calculation of within group and between group variance. Within group variance. Variability within each group. Between group variance. Variability between the group. Two-way ANOVA. Two-way ANOVA involves two independent variables. Application. Example. Studying the effects of two factors such as treatment and gender as a response variable. Analysis of main effects and interaction effects. Main effects. Effects of each independent variable on the dependent variable. Interaction effects. Combined effects of the two independent variables on the dependent variable. Interpretation of results. Examination of F statistics and P values for main effects and interaction effects. Problem. Application of ANOVA. Solve using one-way ANOVA method for the following table. Observation 1, 2, 3, 4, 5. A values are shown below, B, C, D values are shown below. So the presentation of ANOVA first table, that is, we first calculate the sum of A, sum of B, sum of C and sum of D. And then we do the sum of squares table to know the sum of A square, sum of B square, sum of C square, sum of D square as given below. And then next, we find out the n value for each letter. A's n value is 5, B is 5, C is 5 and D is 5. So the total n value is 20. So as we found A value, B, sum of A, sum of B, sum of C, sum of D. So to find sum of xi, we need to add all those. So sum of x is equals to 220 and sum of x square is equals to 2678. Now let k is equals to the number of different samples is equals to 4. So the number of samples is A, B, C, D. So we have taken the number of samples as 4. And n is equals to 20 as we know. So overall x dash is equals to 220 divided by 20, that is equals to 11, or it can be called as CF. Sum of x is equals to 220 as we have seen above, and sum of x square divided by n, 220 square divided by n is equals to 2420. Sum of ti square divided by ni, that is equals to 2470. Sum of x square, that is equals to 2678 as we have seen in the above table. Step 1. Sum of squares between samples. Sum of ti square divided by ni minus sum of x whole square divided by n is equals to equation 3 minus 2, that is 2470 minus 2420, that is equals to 50. So there is an alternative method shown below. So the next step, sum of squares within samples. Sum of x square minus sum of ti square divided by ni That is equals to equation 4 minus equation 3. That is 2678 minus 2470. That is equals to 208. Step 3. Total sum of squares. That is sum of squares between samples and sum of squares within samples. That is SST. So that is 50 plus 208. That is 258. Variance between samples. MSB. That is equals to SSB divided by K minus 1. 50 by 3. The answer is 16.667. Variance within samples. MSW. That is equals to SSW divided by N minus K. So N is 20 and K is 4. K is 4 because the number of samples we have taken is A, B, C, D, so K is 4. That is equals to 208 divided by 16. That is 13. Test statistic F for one-way ANOVA test. F is equals to MSB divided by MSW. That is equals to 16.667 divided by 13. That is equals to 1.2821. The degree of freedom between samples is K minus 1, that is equals to 3. The degree of freedom within samples is N minus K, that is equals to 20 minus 4 is equals to 16. So below table is the ANOVA table representation for the above example problem. We can conclude stating that f of 3, 16 at 0.05 level of significance is equals to 3.2389 as for the f ratio table. As calculated, f is equals to 1.2821 as we got the answer, that is less than 3.2389. So H0 is accepted, hence there is no significant differentiating between samples. Conclusion. ANOVA is a powerful statistical tool for comparing means across multiple groups and or treatments. One-way ANOVA is used for one independent variable, while two-way ANOVA involves two independent variables. Helps identify significant differences between groups, aiding decision making and hypothesis testing. Used to analyze experimental data, compare treatment effects, and assess the impact of interventions. Thank you all for watching. This is it for this video. Let's meet in the next video. Thank you. Do like and subscribe my channel.
From the dust and clean my throat.